Hello everyone. So today we are going to discuss about the overview of power system operation and control. So already we discussed. So what is the objective of the power system operation and control? Okay, you have to maintain the voltage within the specified limit, and as well as you have to maintain the frequency within the specified limit. Okay. So in the overview of power system operation control, so the first point will be considered, that is what is the goal of the power system operation control. Okay, you have to maintain the reliability of the system, so you have to maintain the stability of the system, you have to improve the efficiency of the power system, and you have to consider the power quality also. You have to ensure the voltage and frequency within the permissible limit. Okay, so these are these are very important in the power system operation control and for the sustainability. Okay, so these are all the prime goal of the power system operation control. Okay, so this is the first point will be considered. On for the second point, I have to consider about the function of the power system operation control. So there are different function will be considered. Okay, one is for the load forecasting. So load forecasting means you have to predict the future power demand to prepare the sufficient generation. So for erecting the new generating station within a month or within a year, that is not at all possible. So after 5 years, so how the load is increased, whatever the demand is increased, so based on the increase in demand, how we have to generate the power. And after 10 years or in after 20 years, that is for load forecasting, we have to classify in different types. Okay, so that is why it's a short-term load forecasting, medium-term load forecasting, and long-term load forecasting. For the short period, the demand we have to compensate with the help of the, so we have to predict the future demand with the help of the short period load forecasting. Okay, medium means midterm means that is for it's a 10 years or in 15 years. After 10 years or after 15 years, how the demand it will be increased. Based on that, how we have to manage generate the excess power. Okay, so that's called as midterm. On the long term means after the 20 years, after 30 years, so how we have to manage the demand. Okay, so at to power demand and the power generation both are in equal means it will not disturb the power system network, or otherwise what happen, so in the power system network the protected devices will be energized and it will be trip the circuit. Okay, so the function of the power system operation control, it's a prime important role in the power system operation control. Okay, first point is load forecasting, second one is economic load dispatch. Okay, so it's a very simple. So based on the demand in the area, so you have to allocate the power to the particular area. Okay, allocate generation across available power plants to minimize the operating cost. Okay, like economically you have to dispatch the load to all the consumers. Okay, so that comes under the economic load dispatch. Okay, so the main role of the economic dispatch control is to minimize the operating cost. Okay, with the minimum cost, how it is possible to generate the maximum power and also the satisfy the power demand also. Okay, so this comes under the economic load dispatch. And the third one point is nothing but the unit commitment. Okay, so based on that the need of the demand, we have to decide. Okay, so in each generating station we having the different rating of generating unit. Okay, so based on the demand, we have to as a engineer we have to decide which generating unit you have to commit first and which generating unit you have to commit second and so third, fourth, like that. Okay, so based on the demand, okay, I have to commit the generating unit, that is called as unit commitment. Okay, so and then frequency control means I have to maintain the, for in India, so the frequency is in 50 Hz. Okay, and then plus or minus 3% the tolerance is acceptable in India. Okay, similarly for in US they have maintained the 60 Hz. Okay, so this is for the frequency control, that is fourth parameter. And fifth one is it's a voltage control. Okay, so already we discussed. Okay, so I have to maintain the voltage within the tolerance value. So these are the main function of the power system operation control. Okay, and grid monitoring also it's very important. Okay, to monitor the grid in real time using tools like SCADA and the energy management systems. Okay, I have to monitor the grid lines. Okay, all the parameters I have to monitor. Okay, and I have to give the signal to the generating station or in for its load dispatch center to maintain that parameter within the limit. Okay. And the next one is for the contingency analysis. Okay, access systems performance under various fault scenarios. Okay, and prepare for the mitigation. So that is called as contingency analysis. And finally for the renewable energy integration. Okay, so to use in summer period the solar power generation somewhat generate some amount of power it will be generated. So that is integrated with the that is for transmission line grid lines. Okay, to manage the demand. Okay, during the winter period through the windmill. Okay, so that is power we have to generated. So that power is integrated with the that is why it's a transmission line to meet out the demand. Okay, so in the renewable energy integration is a main role to satisfy the demand nowadays. Okay, so these are the different function of the power system operation control. Okay, so what is the control levels in power systems? There are two type of control levels. One is for its primary control and second one is for its secondary control. Okay, the also third one is also the tertiary control. Okay, so the prime control is nothing but the primary control and the secondary control. Okay, immediate response to the system disturbance. Okay, maintain the frequency and stabilize the voltage through the automatic adjustment in the generator output. Okay, so this comes under the primary control. Secondary control means use the automatic generation control AGC to restore the frequency and the power exchange to their scheduled values. Okay, so in the automatic generation control, so already we discussed that with the PFQB control. Okay, so I had to with the help of the voltage sensor and frequency sensor, I had to sense the voltage and frequency and compare with the rated desired value of frequency and voltage. Based on that, I had to give the commanding signal to the valve for maintain the frequency means I had to give the commanding signal LPC. Okay, to the valve, give the change in command signal to the valve. Based on that, the valve will be open or closed. Okay, so this comes under the secondary control. So tertiary control means involves human intervention to optimize the power dispatch and manage long-term operations. So this is for tertiary control. Okay, and then fourth one main point is challenges in power system operation. Okay, renewable energy integration is one of the challenges. Cyber security is the second one, and aging infrastructure. It's nothing but the older equipment need to upgrade to handle the modern grid demands. Okay, that is why it's the aging infrastructure and the demand variability. So these points comes under we have to consider in the challenges in power system operation. Okay, and the fifth one is key technologies in power system operation and control. Okay, so with the help of the apart from the manual control, okay, we go for this system with the help of the PC. Okay, through the SCADA means supervisory control and data orchestration systems, and EMS means energy management system. Okay, I have to monitor and control all the electrical parameters. Okay, so there is no manual operations. Okay, everything that is why it's computerized with the help of the PC. I have to monitor all the parameters, and based on the change in parameters value, I have to giving the signal to the generating station or in load dispatch center. Okay, so then based on the command received from the SCADA system, so I have to maintain the voltage and the frequency within the specified limit. Okay, and then phasor measurement units also will be one of the key technologies on the smart grids. Okay, enable real-time communication and the dynamic control between the utilities and the consumer. That is also it's a very one important point. Battery storage systems. Okay, so will be also considered, and AI and machine learning also introduced to enhance the load forecasting, fault detection, and decision making. Okay, so these points will comes under the key technologies in power system operation control. Finally, for the importance of the power system operation control. Okay, so efficient operation and control, it will be ensured through the stability and the reliability of the electrical grid, minimization of operational cost. Okay, the cost is the prime importance in the power system operation control. ஓகேங்களா. ஸோ ஒன் ஆஃப் தி அப்ஜெக்டிவ் வித் minimum cost, how it is possible to generate the maximum power. Okay, so that is one of the important point. And for the adaptability to evolving energy demands on the technologies, it's another one important point. So and the last one is for the safe integration of renewable energy sources into the grid lines. So these are the important points will be considered for the efficient operation of power station operation control. Okay, thank you.